Under linked list class, we will first define a method which will append elements to a linked list. Let's add a cell and then definition. So this definition would be under linked list class. Okay, I think I'm doing okay. Okay, definition append, which will take two parameters. It's a linked list class and data which we want to insert. In a linked list, we can add if you have to look at the problem. If the problem says that you have to insert at the tail, then you have to follow this procedure where you have to first initialize the current node with head and then reach to the end of list, make a node with the data. This data will have to make a node and then assign the node. Let's see how we can do that. What we'll do, we'll first initialize current node with self dot head. Okay, and then while current node dot next not equal none, current node is equal current node dot next. After reaching the last node, what we'll do that. So by this time we have reached the end of the list. One thing to notice that you are not doing while current node not equal none. Rather, you are doing while current node dot next not equal none. You don't want to reach at the linked list's last value, last pointer where we point to none, right? If we reach there, we will reach to none and we will lose our linked list address. So we'll have to go till the point where the next wouldn't be none. If the next is none, we will lose our linked list information. So for insert case, we will try to remember this. Okay, and then we will, with the data, we will make our new node. How? Just call the node class, give the data as parameter, and then current node dot next equal new node. So this is how you have inserted your data at the tail of a linked list. Now we'll check whether this is working or not. Let's add another cell and ll is equal, we'll first make a linked list class with 11 and then okay, no, don't have to append suppose 11 and then again append suppose another 11 and then suppose append another 11 and then suppose append 9, we'll append 2 and then again let's 2. But at this point we can run the code and see if there's any. Okay, what happened? Okay, I think I haven't spelled it correctly. I think we have to go in the same cell. And then let's check run, then run, run. Delete this cell, run. Okay, yeah, this is the thing. You'll have to, if you have one class should be declared in one cell. But we cannot see what we have appended right now. For this, we have to append another class, which is display class or print class. We have to define a class like display. The self parameter is masked because that display is within the class. So we will display the linked list. First, we will make a list where we will store our linked list, and then at a time we will print. Current node, let's initialize the current node, and then progress while current node, which means well current node is not null, or you can just write current node my list dot append current node dot data current node assign current node dot next, and then we will print our list. That should do. Let's go for it. We'll first run this one to see whether there's any error, and then ll.display, see whether it's displaying our linked list for us. Run this. Yeah. So yes, we in the with this function we're inserting at tail. What if we have to insert at our head? How we can do that? So what we will do, just comment this part and see how how we can just insert at head. So to insert at head, we have to again make the node with the data where we have been provided, make new node with data, and then initialize current node self.head. No, actually we don't have to traverse the whole list, right? We can use it like our current node is our new node, and then current node dot next would be head, and update our head, because since we're inserting at node head node, so we'll have to redefine the current node as our head node. Okay, and first we will make a node, and then our current node is our new node. We will point the next node of our current node as our head node. Then head node would be the second node, and we will update our head as our current node. Let's see how that works. First run this cell, and then run this cell. See, it had first installed every time anything we have appended, it has been appended as head node and then head node and again head node. So actually we get the reverse of what we have, the order we have appended. Okay, so for now what you have seen that how we can append either in a tail, in the tail of a linked list, or at the head of a linked list. Okay, so our next attempt would be how we can define a function which will insert a value at any position given. Okay, not in the head or in the tail. Let's see how we can do that. So as you notice that these definitions are within linked list class. Now we will just define a class which is not within the class. I'm just doing it. You can also define it within the class, but for now let's see how we can do that. Let's name the function insert at a given index, head, index, and data. Okay, so this function will insert data to the given index position, which is IDX. First initialize index to 0 because this is our index, which we will increase. And current node, let's initialize current node as self dot. Sorry, we won't use self dot head node here. We'll just use head because this is not within the class. Okay, and then we will also have to define our initialize our previous node, because when we insert at any position we have to keep track of the previous position of its previous position, and also you have to keep track of its next position. So previous node is, you can just initialize it to current node for now, and then while current node dot next not equal none if index equal idx. Okay, so when we will try to increment our index. So whenever the index would be would be equal to the given index, we will insert at that position. Okay, so so whenever this condition is met, which is we have found our desired index, let's quickly define our new node, which is, so with the data we'll have to make the new node, and previous node dot next is equal to new node, because we want to, in that index we want, if I need to clarify, I think I need to clarify that. So in the previous, sorry, in the, so we have to insert the data to the next node of the previous node. Okay, and then our new node dot next is equal current node. Okay, and we will increment our index and previous node is equal to current node, and current node is equal current node dot next. So um, these three commands will be executed while this if is not true, right? So suppose index is 2 and our given index is 3. So it will, what it will do, it will increment our index, it will update our previous node to current node, and current node will be current node dot next to traverse the linked list. Let's see whether we can insert at index. Run this. So what we'll do, suppose we want to insert we at number 3 index we want to insert 7. Okay, let's see whether that, and then we will again display our linked list. Insert at IDX. What does it say? Oh, a mistake is here.